Welcome to This Explainer. Have you ever just stopped and wondered how we can mathematically describe something as impossibly large as an entire galaxy, and then turn around and use the exact same framework to measure a single microscopic cell? Well, today we're going on an awe-inspiring journey to unpack exactly that. We're decoding the ultimate language of physics, starting from the foundational rules of units and dimensions all the way to the scale of the universe. Let's kick things off by thinking big, really big. Our physical universe spans distances that are honestly mind-boggling. Just to give you a sense of the extreme macro scale we're operating on here, the diameter of a typical galaxy reaches roughly 10 to the power of 22 meters. Try picturing a 1 with 22 zeros after it. At that point, our everyday concepts of distance just completely break down. Now, zooming in quite a bit, we arrive at our immediate planetary scale. Earth has a diameter of about 10 to the power of 7 meters. It's a massive leap down from the staggering width of a galaxy for sure, but it's still incomprehensibly vast compared to you and me just standing here on the surface. And hey, it's not just physical space we have to think about. When we look at human history, we see a similar kind of vastness. The age of a historical marvel, like the Taj Mahal for instance, is roughly 10 to the power of 10 seconds. So whatever language of measurement we use, it has to seamlessly account for this incredibly stretching scale of time too. All right, let's totally flip the script and plunge in the complete opposite direction, into the microscopic world. Down here, bacteria measure just 10 to the negative 6 meters. I mean, imagine slicing a single millimeter into 1,000 equal pieces. From looking out at the stars to peering through a microscope, our mathematical language absolutely has to keep up. Going even deeper to the extreme microscale, a single strand of DNA shrinks our perspective further, down to 10 to the negative 8 meters. Think about that for a second. The laws of physics and the systems of measurement we use must flawlessly connect the reality of this tiny genetic building block to the swirling galaxy we were talking about just a moment ago. So, how does it all work? Well, here's our roadmap for today. 1. The scale of our universe. 2. Physics fundamental building blocks. 3. The systems of measurement. 4. Navigating extreme proportions. And 5. The secret code, dimensions. Let's dive right into section 1, the scale of our universe. Bridging a gap of 10 to the power of 40 in length and time requires some seriously strict rules. And think about mass for a second. An electron is roughly 9.1 times 10 to the negative 31 kilograms, while our sun is a whopping 2 times 10 to the 30 kilograms. That is an 80 order of magnitude difference. Without a rigid universal system to lock these numbers in place, communicating these realities in science would be literally total chaos. Moving right along to section 2, physics fundamental building blocks. To manage all this chaos, scientists essentially created an alphabet. Think of fundamental quantities like mass, length, and time as the independent, standalone letters of this alphabet. They are absolute. They don't depend on anything else to exist. On the other hand, derived quantities are the complex words we build by combining those letters. You literally can't have the concept of volume without taking the fundamental letter of length and multiplying it by itself 3 times. Which brings us to section 3, the systems of measurement. Okay, so if we have an alphabet, we need universal agreement on what the letters actually are. Globally, we rely on exactly 7 fundamental SI units. We've got the meter, kilogram, second, ampere, Kelvin, mole, and candela. No matter what field of physics you're studying, these are the definitive 7 letters that build absolutely every single measurement in the mechanics of our universe. Next up, section 4, navigating extreme proportions. Now, nobody wants to write out a 1 with 18 zeros behind it every single time they talk about space. So we use macro SI prefixes as a brilliant shortcut. An exa represents 10 to the 18th. A giga is 10 to the 9th. Attach these directly to a base unit, like a gigameter, and you can communicate massive cosmic scales effortlessly without filling an entire chalkboard with zeros. On the flip side, micro prefixes let us dive into the subatomic world with that exact same ease. Micro takes us to 10 to the negative 6, and nano, which rules the realm of nanotechnology as you might guess, is 10 to the negative 9. It's the exact same fundamental unit, just scaled down beautifully to make these invisible fractions completely manageable. And finally, section 5, the secret code, dimensions. This is where we get into the real grammar of our language analogy. A dimensional formula acts like a scientific cheat code, revealing the exact fundamental DNA hiding inside any complex physical measurement. We put the base quantities in square brackets to show we're looking at the pure underlying structure of the measurement, completely ignoring the specific numerical magnitude. Let's actually deconstruct something together. Take the derived quantity of force. Step by step, we break it down until we're left only with mass, length, and time. Force is mass times acceleration. Acceleration is velocity over time, which is essentially length over time divided by time again. When the dust settles, the dimension of force is m to the power of 1, l to the power of 1, and t to the power of -2. That right there is the immutable structural blueprint of force. Now, here is the golden rule of this entire system. No matter what scale or prefix you use, the underlying physical reality remains totally constant. If you measure a table in meters, you get a small number. If you measure that exact same table in centimeters, the number is larger, but the actual table hasn't changed one bit. Magnitude and unit are inversely proportional to ensure reality is perfectly preserved. I'm going to leave you with this empowering thought. Now that you know the alphabet of physics, how will you use dimensional equations to test the reality of the world around you? Think about it. If the dimensions on the left side of a brand new complex scientific equation don't perfectly match the fundamental dimensions on the right, you instantly know the equation is busted. It is the ultimate tool for truth. Thanks so much for joining me on this explainer, and keep questioning the dimensions of your universe.